Bismillahirrahmanirrahim. Welcome to the third part of the 15th lecture of Statistics and Probability Theory. We will continue with the topic Poisson distribution. Example. A new website has an average random hit rate of 2.9 unique visitors every 4 minutes. What is the probability of getting exactly 50 unique visitors every hour? So what's happening here? That average random hit rate of unique visitors is 2.9, but it's in every 4 minutes. Whereas they are asking for the probability of getting exactly 50 unique visitors in every hour. So here's the difference. This average random hit rate is at every 4 minutes, but you have to find out the probability for every hour. Here you can see that lambda is equal to 2.9 unique visitors in every 4 minutes, and x is the random variable which represents the unique visitors. This x represents the number of unique visitors. What about t? So what will be the value of t? Because here we have a hit rate at the rate of 4 minutes, but you have to find out the probability at the rate of 1 hour. So here you can see that x is equal to exactly 50 unique visitors in 1 hour. Lambda is equal to 2.9 unique visitors in every 4 minutes. And you have to find lambda into t. This is basically lambda into t. So you know that there are 60 minutes in every hour. By changing the rate of change, dividing this in with 4 minutes, as this lambda is at the rate of 4 minutes, on average hit rate is 2.9. So this will be equal to 15. So what they did, that they multiplied it with 15. This is lambda into t. We are solving for this into 2.9 unique visitors, and when you multiply this with 15, this will be 60 minutes, which is 1 hour. So lambda into t will be equal to 43.5 unique visitors in 1 hour. So by using the probability mass function of Poisson distribution, which is E of x is equal to e raised to power minus lambda into t and lambda into t t raised to power x whole divided by x factorial. Now you can find out the probability of exactly 50 unique visitors in 1 hour by substituting x is equal to 50 and lambda into t is equal to 43.5. So by solving this, you will get the probability 0.035, which is the probability of getting exactly 50 unique visitors in every hour. Next example. In a factory, the machines break down and require service according to a Poisson distribution at the average of 4 per day. What is the probability that exactly 6 machines break down in 2 days? So what's happening here? That you have lambda is equal to 4, as they are saying that the machines break down and require service according to a Poisson distribution at the average of 4 per day. And you have to find out that what is the probability that exactly 6 machines break down in 2 days. So here lambda is equal to 4 per day and t is equal to 2, and you have to find out these exactly 6 machines break down in 2 days. So x is equal to the number of machines, and here we substitute x is equal to 6 and lambda and t is equal to 2. So this will be equal to lambda into t raised to power x e raised to power minus lambda into t whole divided by x factorial, where lambda is 4, t is 2, x is equal to 6. So by simplifying this, you will get 0.1221, which is the probability that exactly 6 machines break down in 2 days.